So this is 5.3, the metals and extractions topics. The first one is showing you a giant picture of a blast furnace, showing you where the materials go in and where they come out. Raw material, chemical name, you can work that out, so it's iron oxide, and it's a compound because it contains two different types of atoms. Coke then is a source of carbon, normally comes from coal. It's got one atom, so it's an element. And then calcium carbonate is CaCO3. If you weren't sure how to work that out, you could use the ions table at the back. So moving on, these were more blast furnace questions, gave you like a whole example of kind of what happens in the blast furnace. You've got that in a comic strip in your books. State what happens in an exothermic reaction, so relating two topics together. Heat is released into the environment, or heat energy exits. Give one reason why exothermic reaction is important to this process. Ensure all chemical reactions occur. Remember, we talked about how it requires intense heat. So if it isn't an exothermic reaction, you're not getting that intense heat for the reduction. Then it gives you quite a lot of information about plastics. Okay, again, relating another topic to this. So there's 3 topics in this question here. State one way in which each of the savings identified above is beneficial to the environment. So saving 1, space saved, less habitat lost, because they're talking about saving landfill space. Saving 2, no CO2 is released, so it limits global warming. And then again, for this one as well, limits global warming. Another question about the blast furnace, same kind of thing. This was a 6 marker. Okay. Talks about what you have to do. Again, you just have to follow through your comic strip. You've done that one in your book though. And again, blast furnace 1, explain the functions of coke. So coke acts as a source of carbon. Carbon binds with the oxygen to make CO2, so the oxygen from the air. More coke is then added to make CO. Carbon monoxide is then added to reduce the iron oxide. So coke has a really large use in the blast furnace. Moving on to the next question then. This is looking at a displacement reaction between magnesium and copper sulfate. The first thing you have to do is plot a graph of results. Again, they've given you the axes, okay, and it is worth 3 marks, okay, with a suitable line. You can see, when they say suitable line, okay, that can be a curve, but in this case it was just a straight line. Okay, use the graph to find the mass of magnesium needed to form 5 grams of copper. Okay, so 5 grams of copper across and down, working them out. Okay, each of them little squares is 0.02, so it's 1.8. That was the hard bit of that question, was working out how much each one was worth. Okay, remember, so that one would be 0.5, so divide that by 10. Okay, so each little square is 0.05. Copper is obtained by filtering, then washing. State what else can be done to the copper before weighing it, drying it, evaporating it. Complete the chemical equation for the reaction taking place using the symbols. So magnesium is higher up in the reactivity series, so it will displace copper, so it bonds with the sulfate, and then copper's on its own. Okay, I know we've done it as words, but you could do it as chemical equations as well. It then goes on to talk about when copper is added to silver nitrate and they swap over. Okay, grey solid, blue solution, anything that's blue solution will contain copper. So use this information to place copper, magnesium and silver in order. Well, we've already discovered that magnesium is the most reactive. Silver, you should know, is the least reactive, so copper's in the middle. And then I've given a little bit of an explanation there. I've just realised I've written the wrong word there. So magnesium displaces copper, copper displaces silver. So question number 3 on page 8. A known metal X lies between magnesium and iron in the reactivity series. Describe how this could be shown to be true using 3 of the following chemicals. Okay, so you've got magnesium, iron filings, and metal X, a solution of magnesium nitrate, iron nitrate, and a nitrate of element X. Okay, this is a difficult question. Include the reactions that you carry out and the observations that you would expect to make. Okay, so if you added magnesium to iron nitrate, you should get magnesium nitrate and iron, and that's a red solid. Okay, if you added iron nitrate to X, then you'd get X and iron, rusted red solid, and then if you added them together, there would be no reaction. Okay, that's quite hard. I would have just written out what you'd kind of expect to see, focusing on iron being red. Complete the word equation for the reaction of copper and silver nitrate. Well, copper is more reactive, so it'd be copper nitrate and silver. These are the kind of questions we want to use to pick up the 1 marks. Moving on then to an electrolysis question. So question 8, again, can you see every time I do one, I write that panic anagram. State why zinc chloride must be molten. The ions are free to move. It has to be dissolved or melted. Explain what happens at both electrodes. Include relevant half equations. So zinc moves towards the cathode because it's negative, and because the cathode is negative and zinc is positive. Gains electrons, so it's 2 plus. Look that up in your table of ions, so plus 2 electrons. Chloride moves towards the anode, loses electrons, so again minus 1 electron. Aluminium is obtained by electrolysis of molten, look at that word, so it's melted aluminium oxide. Okay, there's an equation for it. State what happens to the electrode aluminium is formed. Give a reason for your answer. State at which electrode. So cathode, opposites attract, so because it's negative. Write a balanced equation for the overall reaction taking place. So aluminium oxide breaks down into aluminium and oxygen. Okay, oxygen's always diatomic. Even if you couldn't balance it, you could have kind of written that out. The balancing was the hard bit, so you could have taken off 1 mark for that. Explain how the extraction of aluminium may contribute to global warming. Uses electricity, produces CO2, too much CO2, global warming. Because it gets stuck in the atmosphere. That's from last year. Aluminium is a good electrical conductor and therefore used to make overhead power cables. Give a different property of aluminium and one use that relies on this property. It's used in cans because it's malleable. You can bend it. So these are the kind of questions that we want to hunt out because this is a graph question. Okay, so the results are given below. It's a person carrying out electrolysis and the results are given below. On the grid, plot the mean mass, so the mean mass and time. They've given you the axes. Okay, draw a suitable line. Okay, I might have actually been a little bit off. Suitable line, this one was a straight line, but it could be a curve. Don't worry, 3 marks in the bag. Everyone should be getting that question right. It then moves on to say at 30 seconds, so at 30 seconds, calculate the percentage variation. So the furthest mass away from the mean mass. Okay, you can use either one. Okay, either 8.2 or 7.8 because they're exactly the same distance away. It just depends whether you get a negative or not. Okay, put it into your equation, times it by 100. Make sure you write out the equation because it is 2 marks so they can see if you lose anything. The difference in mass formed is lower than expected. Give most likely reason for this: improper filtering or drying after the reaction. So another aluminium question. The first question, window frames made from several materials including aluminium and iron. Choose one property from the box which makes aluminium better material than iron. Making window frames, give a reason for your answer. Resists corrosion, so your windows will not rust. Okay, then again, another electrolysis question of aluminium. Which negative ion is attracted to the positive electrode? So you've got aluminium oxide. Might have been worth going to the back of on your table of ions and working out what they look like. So positive electrode, so it's going to be the negative ion, oxygen 2 minus. Write a word equation for the overall reaction. Aluminium oxide breaks down into aluminium and oxygen. Okay, be careful. Remember that when it's an element on its own, it's not oxide anymore. The temperatures of the electrolysis cell is about 1000 degrees. The melting point of aluminium is 660. State the solid liquid gas of aluminium in the cell. Okay, so the melting point means it turns from a solid to a liquid at 660, so at 1000 it's still going to be a liquid. Main reason this process is expensive: it requires so much electricity to run the process. This is a really nice easy question. Okay, there are 5 diagrams arranged, a little bit from last year really. A compound, so 2 bonded together, so it's going to be this one here. 2 different types bonded together. Gaseous element, so something that's moving around loads. Elements, only 1 type. And an alloy is a mixture. Okay, and then you've got a box with loads of different elements and compounds in it. Give the symbol or formula for a compound, so 2 different ones bonded together, and a metal ion, so anything that's got a plus charge essentially. So then you've got a 6 marker all about the uses of copper and titanium. You've got a table of this in your books. So copper conducts electricity, so are good in wiring, will not rust, so used in water pipes and jewellery. Easily malleable as well to make jewellery and water pipes. Copper is used in a saucepan basis, so it can conduct heat. Titanium is low density and lightweight. It is used in thin layers of oxide on the surface, so it is resistant to water and oxygen corrosion. Titanium is hard with a high melting point. This is why it's used in aircraft and hip joints. Last question then.